Good morning, Divya. Good morning, Ekta. Shrutika. Good morning, beta. Okay, shall we start density? Send the link in the group beta and tell everyone to join. So as we know, the density of a substance is defined as mass by volume. So what is density? Density equal to mass by volume of a substance. Okay, density of a substance is defined as mass per unit volume, or density of a substance is defined as mass by volume. Okay, so based on this question, based on this we are going to solve some questions. Ready everyone? Now what is the SI unit of density? Before solving the question, what is the SI unit of density? What is the SI unit of density? What is the SI unit of density? Everyone sleeping right now? Today test is there, na? SI unit of density is kg per meter cube. Yes, the SI unit of mass is its volume. So volume is exactly meter cube, cubic meter, and here mass is in kg. So SI unit is kg per meter cube. Absolutely correct, Shruti. SI unit is, Shruti Ekta, answer is absolutely correct. The SI unit of density is kg per meter cube. Okay, and we know that density of substances are different, like air density, wood density, ice density. Satyashri, good morning, beta. So the different contents are exactly different. Materials have different density. Different materials have different density. So definitely whatever materials are exactly present in what volume, it is defining the density of the substance. It is defining the density of the substance. Means if I will take a big container, you have to understand one thing. If I will take a big container, that means volume will be more and material will be less, then density will be less, because density is directly proportional to mass. So how much is the mass? Density is directly proportional to mass. So how much is the mass? That much will be the volume. Density is directly proportional to mass. How much will be the mass? How much will be the mass? Keshav, good morning, beta. How much will be the mass? Accordingly, we will be getting the density. But next important thing is density is inversely proportional to volume. Density is inversely proportional to volume. So if density will be more, volume will be less. Okay, density will be more, volume will be less. So that is what I said. But Mehrunisa, good morning, beta. So that means we learned one thing, that density is nothing but mass per unit volume, or mass by volume. And most important thing is density is directly dependent on mass. More the mass, more the density, but less the volume, more the density, because volume and density is inversely proportional. Increase of volume will decrease the density. The increase of volume will decrease the density, because they both are inversely proportional. Okay, now one question is there. I think ma'am taught you or not, I don't know, but did she talked about when the object floats in water and when the object shrinks in water, sinks in water? Do you know about this concept, that when the object is floating, when the object is sinking? When the object is floating, when the object is sinking, there is three cases. If you are knowing this case, then one time I am going to discuss and then I'll start the numericals. No? Okay. No, she didn't spoke about it. So one very simple concept is कि when accidentally also if it will come to you, just understand that कि we compare density of water, density of materials. Okay, so density of water and density of material and density of material. So now just understand that density of material. So now understand one thing. Yes, when an object will sink, Ashwin, good morning, beta. Good morning, Ashwin. When an object will sink or when an object will float. So there are 3-4 cases you have to understand. When density of water will be equal to density of material. Like I have taken something, like I have taken a box, okay, and I exactly wanted that box to go inside water, and I want to know that how it is going to behave. Is it going to sink? Is it going to float? Is it going to immerse? How it is exactly going to behave, that I want to know. So for that what I am going to do is I'll check the density of water and density of material. So density of water and density of material, how I am going to check. So now look here, density of material will more than density of water when density of material is equal to density of water. When density of material is less than density of water. So there can be 3 cases. One case when density of material will be more than density of water. So when the density of material will be more than density of water, the material will sink. Okay, it will sink. So if it is water, then the box will go inside water. So this is the concept. Okay, this is the concept that if this is water, the box will exactly go inside water. The box will go inside water. This is first concept. This is first case. The box will go inside water, totally immersed inside water. It will totally go inside water. Okay. Now second condition is when density of material is equal to density of water, then it will be immersed. Immersed completely. Immersed means what? Immersed means immersed means if this is the layer of water, this is the outer layer of water, the box will be exactly here. The box will not sink. The box will not sink. The box will not go up, but it will be exactly inside the water. It will be inside the water. It will not sink. It will be floating like this. If water is there and the object is inside, it will be floating like this. So it will not be totally inside water also. It will not sink and go at the bottom. It will not come at the top. It will be immersed nicely in water. Okay. Now when density of material is less than density of water, then the object will float. How it is exactly going to float? So if this is water, then the object will come on the surface of water. Object will come on the surface of water. Did you understood this concept? That what is density of material will be greater than density of water. Density of material will be equal to density of water and density of material less than density of water. So 3 cases will be there. Density of material is greater than density of water, density of material equal to density of water, density of material less than density of water. So 3 cases will be coming, and all these 3 cases means either the object will sink, object will be immersed, and object will float. Understood everyone? Super. So this is the only concept beta when density will be playing a very vital role at the time when object will be inside water. At the time when the object will be inside water. I hope you might have understood the concept. Now shall we start solving questions, because I think one mark question may come for you. So when 1 mark question chances are there, so we will definitely try solving questions. Now first question is, an object of mass 50 gram has a volume of has a volume of 20 cubic centimeter. Has a volume of 20 cubic centimeter. Then object of mass 50 gram has a volume of 20 cubic centimeter. Calculate the density of the object. Calculate the density of the object. Calculate the density of the object, and after that what they are telling, if the density of water be if the density of water be if the density of water be what is the density of water? If the density of water is 1 gram per cubic centimeter, okay, if the density of water be 1 gram per cubic centimeter, state whether the object will float or sink in water. State whether the object will state whether the object will float or sink in water. Now try this question out. This is a very simple question. You don't have to do big things in this question. An object of mass. So mass is given. What is the mass given to you? Mass given to you is 50 grams. Okay. So mass is given how much beta? Mass is given 50 grams. Now what is the volume beta? Volume is 20 cubic centimeter. Okay. Now next what we have to do? We have to find the density. So we know that density equal to mass by volume. So density mass by volume. So what is the mass? 50 by 20 gram per cubic centimeter. So density of density of object is more than density of water. Density of object is more than density of water. Absolutely correct, beta. So what will happen to the object? The object will dance on water, means it will float on water, or it will sink in water. So it is 100% going to be sink. It is 100% going to be sink. So it's a case of sink. It will sink. It will go inside water. So it will 100% going to be sink. It is going to be sink. Okay. It is going to sink. Very good, Satyashri. It is going to sink. So the simple case coming here is it is exactly going to go inside water. Yes, Ashwin sink. Everybody is saying that it will exactly sink. So now again next question we are going to do. Okay. Now shall we start? So now next question is a plastic bottle of density related to gravitation. 20 grams, correct only. Density related to water she has given. Density related to gravitation she has given. Okay, I have to check that one. I think she might have given pure density related questions. Okay, so now a plastic bottle of A plastic bottle of 500 gram has a volume of like normal questions he has given 450 cubic centimeter. Find the density of the bottle. Oh, she has given like that type of question. Wait, I have to check in the numerical sections. I thought she gave questions from flotation type. Solve this question. Okay, Ashwin has given the answer. So she has given normal density related questions. Can you send me some questions? Because I am having flotation related density questions. Okay. Planet density I don't have. So plastic bottle is given this much, so directly we can get the answer. So density equal to mass by volume. So mass is exactly 500 gram by 450 cubic centimeter. Yes, 1.11. Exactly what is this? I think she just converted this one. Force of attraction or G is equal to mass of the planet she might have taken. Like look here, we already know that when an object will fall, it will have F is equal to mg. Okay, most important thing, it will have F is equal to mg. Now next important thing is the force of attraction between the object by r square will be there. Now we know that it is independent of gmm by r square is there. So that means an object is exactly freely falling concept means it is independent of the mass of the object. So it is totally dependent on, okay, it is independent of mass of the object. So since it is independent of mass of the object, it is totally dependent on the mass of the planet. Okay, now mass of the planet means density of the planet. Density of the planet is equal to mass of the planet by volume of the planet. Okay, mass of the planet by volume of the planet. So exactly she might have done like that. So density into volume equal to mass of the planet. So G will be equal to G, instead of this M, density into density into volume of the planet by R square. Send me the questions, beta, because MCQ questions you will not be giving those type of questions. MCQ questions, in that it will not be coming. For MCQ this will not be coming. MCQ questions, most probably easy questions will be coming. I'll be giving you some questions. Wait, look here. I'm going to give you some questions related to that. Okay, the questions which will be easy to come. These questions will not be coming. Yeah, percentage composition means relative questions will be coming. Relative questions will be coming, but not to that level these questions will be coming. Percentage increase you can be able to find. Ayo. Then send me those questions after class. I'm going to solve and I'm going to send those questions. If it will not come, then seriously. Comparison related questions she can ask. Comparison related questions he can ask. Okay. Now wait, I'll give some questions. The weight of a boy on the surface of Earth is 294 Newton. Find its mass. First part solve. What will be its mass? Find its mass first. Ma'am, we are confused from where did she give like this question for exam? She will not be giving. First thing is there. It's an MCQ session. In MCQ sessions, she cannot give questions like that. In density chapter, first thing is that this type of questions, it will be like, so you know that weight is coming as M into G. So it is exactly what is given. 294 Newton is given. 294. Mass is given as, the weight of a boy on a surface of Earth is given as this much. So 9.8 meter per second square if we will take. So mass will be equal to 294 by 9.8 kg. Then you have to solve. So approximated answer will be coming 30 kg. Approximated answer is 30 kg is going to come. Okay, wait, I'll give you some questions which is related to gravitation chapter. I don't think so that type of questions will be coming. 30 kg is approximated, 30 kg is going to come, or those questions which are very very typical, you do send me after class. I'm going to solve. Okay, now one question is, calculate the force of gravitation. See, those questions which can come for MCQ, first I'm going to give those questions. Ekta, absolutely. Oh, it is solving, it is exactly going fine, no problem. Now look here beta, first question which is exactly concept of free fall. What is the concept of free fall? 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 Anyone type and send? I'll see those questions. Don't worry. What is the concept of free fall? 294, it will be exactly going to get divisible, no problem. 98 divided 98 into 3 is coming. A body falls, a body falling only with the help of the gravitational pull of the planet. It is exactly the concept of free fall. Anyone else who can give the concept of free fall? Only Keshav has given the concept of free fall. Anyone else who can give the concept of free fall? Ashwin, when an object comes from a height when no force attract other than gravitation is concept of free fall. Is it the answer for concept of free fall? Means when an object is falling free truly under the influence of gravitational force, no other force will be acting on it, then it is a concept of free fall. It is a concept of free fall. Exactly, a body falling towards the earth under the action of gravitational force. Under the action of gravitational force alone will be exactly giving us the concept of free fall. Then one experimental verification I have discussed. In that experimental verification, one coin and one fur, both of different masses we have taken, and then we were trying to understand that which one will fall first. So what answer is going to come? Without air resistance is very important point. See, air resistance should not have to be there, okay, because if air resistance will be there, then air resistance will influence the free fall. Air resistance will influence the free fall. Now one small question, I'm just Jiva, good morning beta. So air resistance is going to stop it. Now one last question I'm just going to ask from this, that vacuum concept of, okay, one fur and one coin was there. When it will hit the ground, they both have exactly thrown from a height at the same time. Then when it will hit the ground, which one will hit the ground first? Means I just want to ask that which one will hit the ground first? Which one will hit the ground first? Which one will hit the ground first? Coin will hit. Bah, super. Very good. If there will be no resistance, which one will hit the ground first? both will hit the ground. It is not vacuum, air resistance will not be there. Air resistance will not be there. If air resistance is not going to be there, then both of them are going to hit the ground same time, because already you know that one thing is there, that when a body is exactly having a free fall concept. First though, I know which type of question is going to come. So first important thing you have to remember that when body is exactly having a concept of free fall, then both the bodies are exactly going to hit the ground same time if air resistance we are removing. And second important thing is we know that it is totally under the influence of gravitation, acceleration due to gravity, that is the gravitational force. And mass of the object, where is the mass of the object? It is free from the mass of the object. At the time of discussion, we have already discussed this point. We have So one statement I am going to read out, just tell the answer. One statement I am going to read out, just tell the answer. The magnitude of velocity of freely falling body goes on increasing at a constant rate. Is the statement true or false? The magnitude of velocity of freely falling body goes on increasing at a constant rate. The magnitude of velocity of a freely falling body. The magnitude of velocity of a freely falling body goes on increasing at a constant rate. The magnitude of the velocity of freely falling body, the magnitude of velocity of a freely falling body goes on increasing at a constant rate. Goes on increasing at a constant rate. What does this statement says that? This statement is exactly saying one thing, that the more the object will come near to the surface of earth, the more the gravitational pull will increase. So if the gravitational pull when the object is coming near to the surface of earth keep on increasing, that means the velocity with which the body is going to strike the surface of earth will keep on increasing with a constant pace, will keep on increasing at a constant pace. And that is what the velocity before hitting the ground of an object will be maximum. The velocity of an object before hitting the ground will be maximum. The velocity of an object before hitting the ground will be maximum. Okay, the velocity of the object before hitting the ground will become maximum. Just a fraction of second before hitting the ground, the velocity will become maximum. So this statement is absolutely correct. This statement is absolutely correct. Now next important question is, okay, now what is the effect of altitude on gravity? What is the effect of altitude on gravity? What is the effect of altitude on gravity? Altitude means height. So if I am going to keep an object to very high, means 1000-storied building, and if I am going to keep an object and 10-storied building, what will be the effect on the object? Or what is the effect of gravity on the object? An object kept at 1000-storied building and an object kept at 10-storied building. Yes, so that means one thing we know, that the gravity, the more we are going away from earth, the more gravitational pull will decrease. So the more we are going towards the surface of earth, the gravitational pull will be exactly increased. The gravitational pull will be increased. So effect of gravity will be, yes, gravitational decrease, that is gravitational acceleration decreases with altitude. Okay, or we can say that the acceleration due to gravity will be exactly pulling the object more when it is near to the surface of earth. It will more have attractive force, but if it will be away, the attractive force will be less. If it will be away, the attractive force will be less. One question I am going to give, just solve this question. Solve this question. What will be the acceleration due to gravity? What will be the acceleration due to gravity? What will be the acceleration due to gravity at a planet whose mass is 8 times the mass of Earth. Whose mass is 8 times the mass of Earth and whose radius is twice that of Earth. Whose radius is twice that of Earth. Whose radius is twice that of Earth. Take G equal to 10 meter per second square. What will be the acceleration due to gravity for such planet? What will be the acceleration due to gravity for such planet? After the class, send me those questions what ma'am has given. We'll see that questions. I'll solve and send. Maybe she has given 1-2 questions like that. I'll be solving and sending you the questions so that it will become easy for you to attempt. Okay, Keshav has given the answer 20 meter per second square. Shrutika has given the answer 20 meter per second square. So now look here. Exactly what is given to you. What will be the acceleration due to gravity of a planet? So now one planet is there. Just understand. One planet is there. Let us take the name of the planet as X, and one planet is there, that is Earth. Now what they are telling, that mass of this planet X is, mass of Earth is me. Now mass of this planet X is exactly 8 times to that of the mass of, so it is exactly given that it is 8 times to that of mass of Earth. 8 times to that of mass of Earth. First part. Now what is the radius of this? So radius of this planet X is exactly given twice to that of, so radius of Earth is RE, so it is exactly twice to that of Earth. So radius of this planet is twice to that of Earth. Mass is exactly given that much. Radius is given that much. Just 1 minute. Okay, so what is the condition given here is mass of this planet is 8 times to that of mass of Earth. Radius of this planet is twice the radius of this one. Now what we have to do? What we have to do here? So now all the important conditions are given here. So now we have to just start the formula, because we know that acceleration due to gravity, so gravitational acceleration due to gravity of Earth will be what? G me by radius of Earth whole square. This is for acceleration due to gravity of Earth. So what will be acceleration due to gravity for this planet? So for planet X, acceleration due to gravity will be G mx by radius of this planet whole square. Okay, now the condition given to you is mass of this planet is 8 times to that of Earth. So shall we write? Take this as equation 1. So mass of the planet is 8 times to that of Earth. So acceleration due to gravity 8 times to that of Earth is 8 into mass of Earth. So now radius of it is twice to that of Earth. I just substituted the values. So once I substituted the value, what I am going to get is G 8 me by 4. This, so it is coming as 2. So G 2 part I am just going to take here. 2 part I am going to take here. Now it is coming as G me by re square, and G me by re square, G me by re square is exactly what? It is exactly what? It is the acceleration due to gravity on Earth. So it is exactly going to come as 2 into GE, and we know that GE is 10. So acceleration due to gravity of that planet is 20 meter per second square. Acceleration due to gravity of that planet is 20 meter per second square. Okay. Now next question is, yes, absolutely correct. Now next question is, one question exactly, next question, what question is going to, I'm going to give is based on the concept of gravity only. Now look here, question is, a ball is thrown up with a speed of, a ball is thrown up with a speed of, with a speed of 15 meter per second. 15 meter per second. How high will it go? How high will it go before it begins to fall? You have to take G as 9.8 meter per second square. Okay, how high it will go before it begins to fall? Solve this question. How high it will go before it begins to fall? Give the answer. Shall I solve? So 100% when a ball is thrown up with a speed of, so 100% what is there? The situation is ball is exactly thrown up with a speed of, so initial speed given is 15 meter per second. Okay, but what is the problem here is it will go to certain height and it will stop. So there the velocity will become 0. So from the point when the velocity becomes 0 and from the point where it has started its journey, total distance is taken as h. Okay, total distance is considered to be h. Now next is, so what equation we are going to do? What equation we are going to h? what equation we are going to use? So here v square minus u square is equal to 2gh. This equation only we are going to use. The reason behind is v square minus u square, final velocity minus initial velocity by minus, because we have to find height, and g they told us to take 9.8. So final velocity is 100% going to be 0. And then what is u? U is 15 square equal to 2 into 9.8 into h. So 9.8 will be positive or negative. Since the object is doing work against gravity, so acceleration due to gravity will be negative. So it is 9.8 into h. So minus 225 by 2 into 9.8 equal to minus h. H and h will get cancelled. H and h will get cancelled. So 2 point at h and h will get cancelled. So it is exactly going to come as, this will go and 0 will come. So 2250 by 2 into 98. So it is exactly going to come as 1125. 98 will be there. So 98 divided by 1125. What answer is going to come? Till now no answer came. 11.98. Okay, only Shrutika has given the answer. So 1 is coming as 98. So 12 minus 8 will be 4. And 10 minus 9, 145. Again 98 2 times. So again it is going to come as 1. So 98 is coming. 15 minus 8 will be 7. And here it is going to be 13 minus 9 will be 4. So now decimal 0. So 11 point, if we will take 4, 4 8s are 32, 4 9s are 36, 37, 38, 39. Now 98, 5s are 5 8s are 40, 5 9s are 45, 49. So it is exactly going to come as 4, 392. So 10 minus 2 is 8. Then 16 minus 9 will be 7. Okay, 16 minus 9 will be 7. So 78, this much is coming. So 98, 7s are 7, 8s are 56, 7 is 63. So approximated 11.46 meter it will reach. 11.46 or 47 meter it is going to reach. Okay, 11.46 or 47 meter it is exactly going to reach. Approximated height it will reach to that much. Okay, one more question is there. Write the question. I think I should give some comparison questions. Planet comparison questions. Wait, just 1 minute. Yeah, approximated you can say. Question is, a body of mass 1 kg, a body of mass 1 kg, a body of mass 1 kg is placed at a distance of 2 meter, is placed at a distance of 2 meter from another body of mass, from another body of mass 10 kg. At what distance from the body of, at what distance from the body of mass 1 kg another body of mass, another body of mass 5 kg be placed so that the net force of gravitation acting on the body of mass 1 kg is 0. When can the force of attraction be equal? Try this question out. A body of mass 1 kg is placed at a distance of 2 meters from another body of mass 10 kg. Tell the answer. Anyone? Shall I solve? Shall I solve the question? So now look here, one simple concept is given here. First thing is that you have to understand that the body is exactly having, this body is having mass 1 kg. It kept at a distance of 2 meters from a body whose mass is 10 kg. Now we have to find 1.414. Shrutika, okay. So now if that body is kept, we don't know the distance of this. Shall we take it as x meter distance? And this is exactly 5 kg. Now the most important point here is, exactly we know that F is equal to G m1 m2 by r square. So we are going to take this as m, this one is m1 and this as m2. Now one very important point is that is going to connect this one and this one, and that important point is that at what distance from the body of mass 1 kg another body of mass 5 kg be placed, so that net force of gravitation acting on the body of mass 1 kg is 0. That means the force of gravitation is going to be same. So net force means force from this side, force from this side. It is exactly 0. So since net force is 0, so 100% force of attraction, that means we will take it as A, we will take it as B, and we will take it as C. So we can say that force of attraction of B on A is equal to F. Force of attraction of B on A is equal to G. B on A is G m m1 by r square. Distance is given, r1 is given, so we have taken here r as x. Now force of attraction B on A, force of attraction C on A, C on A is equal to G M m2 by r square. Now since it is the net force is 0, so that means they both will be equal to each other. So force of B on A will be equal to force of C on A. So G M m1 by r square G M m2 by r square. So we can take this one is coming as m2 part is coming as this part is taken as x square. G M cancelled. So what is m1? m1 is 10 kg. Distance is 2 square equal to m2 is 5 kg and this x square is there. So x square equal to 5 into 4 by 10 will be coming. So x square is equal to 2. So x equal to root 2. So since x equal to root 2, it will come 1.414 meter. 1.414 meter. So x is coming as root 2 and root 2 can be considered as 5.414. Understood everyone? Understood this one? That the net force is exactly going to come the same. Net force is exactly going to come same. So x will be equal to 1.414. Yes, root 2 meter can be written. You can also write root 2 meter. If you don't know the value, you can go for root 2 meter directly. You can, only one thing is there, that since it is exactly of 1 kg, it is placed at that distance from both the masses, that its net force is 0. Net force is 0 means force given by this side is equal to force given by this side. So since net force will be 0, we can compare the force. So now I am going to keep it till here. You revise the questions. Whatever doubts are there, that questions what your ma'am has given, I really want to see those questions. So send me the questions fast. I will solve and send in group. Okay. So going to keep it till here. Start revising fast. Start revising fast. And whatever doubts will be there, just message me.